Okay, so yeah, we have the video from the Geocentrist titled "The Static Earth, the Geostationary Model Works." And I'm clicking through it a bit. Um, just for context, I'll put it a bit better in the video editing. But he basically went to this website. Now you may notice something. um, it's maybe a bit of a glaring problem for the geocentrist is that this website shows a heliocentric model, which, well, is not really that surprising to most people. Why it would do that? Sorry about the moped noise. Um, but yeah, well, I figured out what he did. He added trails, added from the observer Earth a trail. Oh, hang on. From the observer Earth a trail to Mercury. From the observer Earth a trail to Venus. From the observer Earth a trail targeting Mars. A trail from Earth targeting Jupiter, which he made green, I think. Let's see if we can reproduce it in its entirety. From Earth to Saturn. Another one from Earth to Uranus. And finally, well, not finally, but finally, we're about done. Now, the really silly thing, all he did was, instead of focus on the sun, he focused on the Earth. And if you then turn down the orbit brightness a bit and turn up all the thrill lengths, which I should have done straight away, but hey, why not? You get exactly his video. Right. Now the really stupid part, and that's probably saying something. The really stupid part is, in my video, I'm putting the orbit brightness even lower as his. In his video, you can still clearly see. Anyway, yeah, that should about cover this video. He plays around with speed a bit, and I'm not really bothered by reproducing it in its entirety. But yeah, that about does it. The funny thing is, if you go through the built-in tours, there's a tour of retrograde motion, which starts with the text and the view of our solar system. This is a view of the solar system which shows it as we understand it to be. The Sun is in its center and the planets orbit at varying speeds. Notice how the outer planets move much more slowly than the inner ones. And that's something you may want to remember because we'll get around to a bit of mechanics in a different video. Um, this is the same view with the orbits turned off. If you watch the planets move across the sky from on Earth, they move in a very funny way. Let's take a closer look. And this is probably how he figured out how to make his video. Because this starts with, now let's put the Earth in the center. Poink, Earth in the center. This will give you an idea of the motions of the other planets from Earth's point of view. Early astronomers had to make their models of the solar system from what they could see, and they had to make years of careful observations. Many at first assumed the Earth was the center of the universe. Now the planets are still keeping to their orbits, but it looks odd as we are keeping the Earth in the middle. Let's turn on the orbits. Remember his video. That makes things a bit clearer. We can see that the planets are indeed sticking to their orbits. Now let's look at Venus. Can we see the path that Venus traces through the sky? Turning on trails will help. Let's wait a minute and watch the trail form. It makes an interesting curve, doesn't it? By chance, the relative speeds of Earth and Venus orbits mean that a five-sided pattern emerges. See how Venus seems to spend a lot of time moving slowly around the Earth and then quickly comes in, goes backwards, and then accelerates off again. And this is called retrograde motion. Let's see how close Venus gets. Wow, at its closest, Venus is 4 times closer to us than the Sun. Now, yeah, that's also a thing I read in the comments, like, oh, scales, blah, blah, blah. But really, if you do this at accurate scales, the Sun is still quite big and the planets are invisible dots because your screen doesn't project pixels that small and wouldn't convey the message. So in general, every time you see anything from space, it's not quite using an accurate scale. And there's a beautiful website demonstrating that. We literally have to scroll for many, many minutes to traverse just the distance from Sun to Venus. But I'm getting sidetracked. Okay, now we are using astronomical units. An astronomical unit is the mean distance between the Earth and the Sun. A lot of kilometers. How useful. Now we know about retrograde motion. Let's look at something else. Jupiter's motion in the sky. Jupiter moves much more slowly. And yeah, now you're getting to the a bit more of the view that he had. Almost 12 Earth years. Let's increase the speed. That's better. Blah 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 blah. Yeah, they're going to turn the orbits on again as well. That ends the lesson. What would the Earth's motion look like to a Martian? Yeah, because in this case... Anyway, the main gist of it is it's kind of silly to use a website showing a heliocentric model to make a video showing a supposed geocentric model. And fortunately for us, he has 5 other videos to rip apart.